Welcome back. So this is an extension from section 7.6 in your textbook. This material that we're going to go through here is going to help a lot as we get into chapter 8, as well as the material covered in Algebra 2. You're going to see a lot of these equations also in geometry. So I'm trying to prepare you in Algebra 1. Although this exact material is not part of this textbook, you will see it a lot as you move forward. So here we go. Before we get into the actual topic of solving quadratic equations by factoring, I want to do a review. This is from a couple of sections ago, where I gave you a problem like this, where it was already factored, so the product of two binomials, and it was set equal to 0. So we're multiplying two factors and getting out a 0. So remember from the past, we talked about the zero product property, and what that says is if you are multiplying two or more factors together, so something times something, and you're getting out a 0, well, what must be true of one of those two somethings, one of those two factors? Well, the zero product property tells us that one of them must equal 0. There's no other way to get out a 0 when you multiply unless you're multiplying by a 0. So one of these two factors must equal 0. I'll write that here. One of these must equal 0. One of these must equal 0. That's the zero product property. And we are going to use that same idea with this problem here. We are multiplying two factors together and getting out a 0. So what does one of these two factors have to equal? Well, one of them must equal 0. So we have two possible cases. Case number 1 is that x minus 2 equals 0. Or case number 2 is that x plus 5 equals 0. If either one of those factors is equivalent to a 0, so you could just replace it with a big old 0, then 0 times anything will give you out a 0, and that would be a true statement. So we're trying to find the value of x that turns this expression, x minus 2, into a 0. Some of you are looking at this and going, well, obviously 2, plug in a 2, it makes it a 0. But I still want to show my work here just to show how you would go about solving one of these, because they will get more complex as we move on with math. So add 2 to both sides, we end up getting x equals 2. Or on this one, subtract 5 from both sides, and we get x equals negative 5. So remember from a couple of sections ago, we wrote our answers in set notation, and we put them in numerical order. So the smallest or least number goes first, and the largest or greatest number goes last. And those are my answers. So just to review this real quick, if you plug in a negative 5, you get negative 5 minus 2 here, which is negative 7. That's not a 0, right? But that's okay, because when I plug in negative 5 here, that turns into a 0. So negative 7 times 0 is 0. That is why that's a solution. It makes that equation true. If I plug in a 2, 2 minus 2 is 0. 2 plus 5 is 7, but again, that's okay because we have 0 times 7, which is 0. So again, plugging in a 2 makes that equation true, and that's why that is one of our solutions. So that's just a quick review from the past. So let's go ahead and apply this idea into the new material, which is really combining factoring trinomials with the zero product property. So the section is titled Solving Quadratic Equations by Factoring. So what exactly is a quadratic equation? Well, I'll define it right here for you. A quadratic equation is a nonlinear equation that can be written in standard form, ax squared plus bx plus c equals 0. It has a condition that a cannot equal 0, because if a was 0, that would turn this entire term into a 0. You'd have just a big 0 here, so you'd end up with bx plus c equals 0, and that would be a linear equation. And right here it says a nonlinear equation, so that's why a cannot be 0. So if you can write it in this form, it's a quadratic equation. So that should look, this left-hand side should look pretty familiar from the last couple of sections. You've been factoring these trinomials up to this point, and now we're going to set them equal to 0. So the process of solving quadratic equations by factoring, you're going to take the left-hand side here, you're going to make it look like this, ax squared plus bx plus c, so that you can factor it. So the first step, we're going to factor this ax squared plus bx plus c. And then the second step will be to apply the zero product property. Apply the zero product property. And that's what we were just doing on that the last slide. So that's what we're doing on this one here, where we set each of these factors equal to 0, because if you're multiplying two factors and getting out a 0, one of the factors must equal 0. So those are the steps we're going to follow for this lesson, solving quadratic equations by factoring. So here's the first example. So you have a trinomial set equal to 0. Again, a trinomial is factorable if it can be written as the product of two binomials. We're still going to have the equals 0 carried down throughout our work. So what is the factored form of this trinomial? Well, the first term is an x squared, so that tells me I need an x times x. And the outside two must multiply together to give me a positive 2. So that tells me I must have a plus 1 and a plus 2, because 1 times 2 is 2. So you could double check this. X times x is x squared. We'd get a 2x on the outside. The inside is x. 2x plus x is 3x. And 1 times 2 is 2. So that is the factored form of that trinomial. And now we apply that zero product property. So if we are multiplying these two factors together and getting out a 0, one of them must equal 0. Either x plus 1 equals 0 or x plus 2 equals 0. Solve each one of those, we get x equals negative 1 or x equals negative 2, and write your answers in a set with the least number going first. So that's the process of solving quadratic equations by factoring. There are a couple more, slightly more complex problems that we're going to get into, but really that is what you have to do. You factor and then use the zero product property. So on this one, it's the same thing, but remember, if you have a greatest common factor, you always want to take that out, factor that out first, so that you're dealing with smaller numbers and so that your answer is factored completely, or your factored form is factored completely. We don't want any factors with greatest common factors left in them. So factor out the greatest common factor. In this one, the greatest common factor is 3, because all of these terms are divisible by 3. When we factor out 3, we're left with x squared plus x minus 2, and it still equals 0. So just like on that last lesson, we are going to be looking at this trinomial. We're going to carry that 3 down throughout our work, and we're going to factor that trinomial, and it will still equal 0. So in the first two positions, I have an x squared that these first two need to multiply to, so I must have an x and an x. The outside 2 must multiply to negative 2, so I must have a positive 1 and a negative 2. Oh, but hang on a second, I need to have a positive 1 in the middle, so these two are going to have to multiply to give me a negative 2, but add to a positive 1. So that tells me I made a mistake. This should be a negative 1 and a positive 2. So let's double check that. X squared plus 2x minus x, that's positive x, and then minus 2. Sure enough, that's good. All right, so on this one, we again have 3 factors getting multiplied together, and their product is 0. So that zero product property tells me one of the 3 factors must equal 0. But here's the thing. 3 will never equal 0. There's no way to turn a 3 into a 0. There's no variable in this expression, so we don't need to consider this when we're trying to find the values of x that turn this side into a 0. So yes, there's a factor here, but 3 will never equal 0, so we can ignore that one. So we say x minus 1 equals 0, or x plus 2 equals 0. Solve those, we get x equals 1 by adding 1 to the other side, or x equals negative 2 by subtracting 2 from both sides. So in numerical order, we write negative 2, 1. Those are our 2 solutions. All right, we have 2 more examples to go. On this one, you might notice it's a little bit different than the previous 2 examples because, well, it's not equal to 0. And why do we need this equal to 0? Hopefully you're saying, so we can use the zero product property, or at least hopefully you're thinking it. If not, that's okay, but that's why. We need a 0 so we can apply the zero product property. Never had to write so much with a mouse before. All right, here we go. So how do I get that 6 to the other side so that equals 0? Well, subtract 6 from both sides. That will cancel that one out. We'll be left with an equals 0. And again, we want that so we can use the zero product property. On the left-hand side, we have 2x squared minus 4x minus 6. But don't think, oh, we have to factor right away. We always want to look for the greatest common factor. And in this one, we do have a greatest common factor. We can factor out a 2. And what remains is x squared minus 2x minus 3, and it still equals 0. And now we're going to factor this trinomial, x squared minus 2x minus 3. So we have a product of two binomials. My first term is x squared, so my first two positions must both be x. I need the last two to multiply together to give me a negative 3, so I'm thinking negative 3 and positive 1. Either it's negative 3 and positive 1 or positive 3 and negative 1. But let's see, do we get that negative 2x? Well, x squared plus x minus 3x. A positive x minus 3x is negative 2x, and then the last two together would give us a negative 3. So that is the factored form of that trinomial. So again, now we're going to use that zero product property. So just like the last one, we have three factors getting multiplied together, and the product is 0. 2 can never equal 0, so we don't have to consider that. We just have x minus 3 equals 0 or x plus 1 equals 0, and we'll solve those to find the values of x that would turn this left-hand side into a 0. So add 3 to both sides, we get x equals 3, or subtract 1 from both sides, we get x equals negative 1, and write your answers in a set. So the only difference on this example to the last one compared to the last one is we had to get it equal to 0 first before we could start that same process that we did in the previous example. All right, the very last one here is very similar to one of your homework problems. Actually, I can tell you which problem it's similar to here. This is very similar to number 18, and some of you might have realize I just open up your homework and you're seeing an answer key and you're like, oh my gosh, I need to pause this. Don't worry, I'll provide the answer key on this assignment. I'm not worried about if you know the answers, if you can see the answers. I mean, some of you could just use photomath, whatever. I'm looking for your work when you do these problems. So I don't mind showing you some answers, but please show me your work as you do these. That's really where I'm going to know if you're understanding the process or if you're just writing down answers from photomath or whatnot. All right, so on this one, again, we need to get everything onto one side of the equal sign because we want it equal to 0, because we want to use that zero product property. And I might as well just copy this right on over to the other page. It's the exact same idea. We need this equal to 0 so we can apply the zero product property. So subtract 22k from both sides, subtract 4 from both sides, and we'll get that equal to 0. So 35k squared minus 22k plus 3, because if I subtract 4 from both sides, that turns into a 3, and that equals 0. So that's your first step. Now it's just like the previous example. We look for a greatest common factor, and then we have to use the zero product property after we factor. So the first thing, is there a greatest common factor? Well, here I see a 3. So 3 is a prime number, so if there's a greatest common factor, it would have to be a 3. So you look at your other two coefficients here, and are they divisible by 3? And the answer to that is no. 30 is divisible by 3. 36 is divisible by 3, but 35 is not. 22 is not divisible by 3. 21 or 24 would be divisible by 3, but neither of these are divisible by 3, and we would have to have all three of these terms be divisible by 3 to have a greatest common factor. So there's no greatest common factor here. So right away, I need to try to write this as the product of two binomials, and it still equals 0. Now this one's a little bit tougher. These numbers are bigger than numbers that you've been dealing with so far, but that's okay. The process remains the same. The first two positions need to multiply together to give us this 35k squared, and the last two positions have to multiply together to give us a 3, which that one's not bad because that's a prime. We're not going to have too many options there. So what numbers multiply together to give you a 35? And then we'll obviously have to have the two k's that multiply together to give us a k squared. So what values multiply to 35? We're just going to try some scenarios out, and I'll just try them over here. So how about 5 and 7? So using 5 and 7, multiplying those together, we get 35k squared. That's what we need there. Right here. We need to get a 3 on the end, so I'm thinking I'll need a positive 3 and maybe a negative 1. And I'm using a positive and negative. I'm sorry, we need to get a positive 3, so I need to use two negatives. I'm using two negatives because I see here my middle term has to be a negative. So I need two numbers that multiply together to give me a positive 3, and then I'm going to have some negative k's to add up to this negative 22k in the middle. So let's see, if I FOIL this out, do I get that trinomial? So 5k times 7k squared. 5k times 7k is 35k squared. The outside two multiplied together give me a negative 5k. The inside two gives me a negative 21k. And the last two gives me a positive 3. Combining those like terms together, we get 35k squared. Minus 26k plus 3, and that is not quite what we needed in the middle there, so this is not the factored form of this trinomial. So we try out another example, another possibility. So let's go with, I'll still try 5k here and a 7k in the other first position of the other binomial. So I have 3 and 1. It has to be 3 times 1 to give me that 3. There are no other options. They both have to be negative so that I will have enough negative k's to combine together to give me the negative 22k. So I tried 3 and 1 there. Let's just flip-flop them and see what happens if I try 1 here and 3 here. That's my only other option. So let's see. 5k times 7k. If I FOIL these together, I get 35k squared. The outside two together gives me a negative 15k. The inside two together gives me a negative 7k. And the last two getting multiplied together gives me a positive 3. Combine those like terms, I end up with 35k squared minus 22k plus 3. And sure enough, that trinomial is the same as the one that we started with. So 5k minus 1, 5k minus 1, and 7k minus 3, 7k minus 3. That is the factored form of that trinomial. And now that we factored it, we will apply that zero product property. If we're multiplying two factors together, getting out a 0, one of those factors must equal 0. So either 5k minus 1 equals 0, or 7k minus 3 equals 0. Solve those two equations to get your answers. So add 1 to the other side, we get 5k equals 1. Divide both sides by 5, we get k equals 1/5. And yes, that's okay to get fractions as answers. Add 3 to the other side, so we get 7k equals 3. And divide by 7, we get k equals 3/7. So my final answers, written in set notation in numerical order. 1/5 is 0.237 is just a little less than a half, so 1/5 should go first, followed by 3/7. And there we go. So on this one, yeah, we looked for greatest common factor. A greatest common factor did not exist because not all of them were divisible by this 3. This was a prime number, so I knew 3 was my only possible greatest common factor, but it did not. 22 and 35 were not divisible by 3, so it didn't have a greatest common factor. So I went right into factoring, trying out a couple of possibilities until I was able to factor it. Writing it in factored form, using the zero product property, I set each one of these factors equal to 0 and solve to get my answers. And again, fractions are okay. So just to show this to you, on the worksheet for homework, there are going to be quite a few that have fractions. Some of these are wrote as decimals, but you could write these as fractions as well. That's okay. But I will again share this answer key with you with the actual worksheet, so you'll be able to see the answers. Please try to do these without looking at the answers first. Just use the answer key to double check your work, and that will help you in the long run. All right, if you have questions, hopefully you know what to do by now. Either send me an email or contact me at the phone number that is on that handout that I also put on Schoology. Thanks.